All right, everybody. So I still have you can see I still have the equations in from the last time we were together. I'm just gonna delete these out of here. Okay. So the first equation that we are graphing is 2x. Notice how I started parentheses here because I know I'm going to be dividing. 2x plus 5 is the numerator, so the whole numerator should be in parentheses, divided by the whole denominator should be in parentheses, so we have 3x squared plus 1 and the parentheses. And now I'm ready to graph. I just want to make sure that my window is the standard window. There it is. Okay, when I look at the end behavior here, I can see that on the left side of the graph, it does look like it dips below the x-axis for just a little bit between -4 and -6 here, -7. But then it comes back up and it looks like it's just becoming the x-axis. And the same thing in the right direction. Now, it's hard to look at this graph and see that, but it looks like the function is approaching 0 from both sides. We can confirm this by using the table feature on our calculator. So if you hit second graph, you get a table. And now my table's filled out, but if you want to be able to put in your own x values here to try out yourself, you can change that feature, and I actually recommend it. So if you hit second window, you can see I get my table set up here. And instead of letting the independent variable be auto, you can change it to ask. And if you change it to ask and go back to your table, now your table's empty and you can plug in any number you want. Now remember, we're talking about end behavior here, so we want to plug in like large numbers. Okay? Now I plugged in 100,000 and I got 6.7 times 10 to the -6, which is really 0.000067, which is a really small number. It's really close to 0. Okay? But end behavior isn't just really big positive numbers, and I could go even further positively. So let's do 1,000,000. So that gives me 0.00000067, which is really close to 0. Okay? But let's try it in the negative direction. And it's important that you use the negative key down here, not the minus sign. So negative 100,000 gives me -7 times 10 to the -6. So that's 0.000007, which is really close to 0. And if I put in a -1,000,000, I get that same really close to 0 number. So it looks like the end behavior for the first equation is going to 0 as x goes to -infinity or +infinity. Y, or f of x, is approaching 0. Okay, and I'm actually going to write this on the notes that I have, and we'll come back to those notes in the next video. So y equals 0 was the horizontal asymptote. I'm writing that down. Let's move on to the next one. Okay, I'm going to go back to y equals, and the only difference between the first and the second equation was that the second one, the numerator had this being x squared. That didn't work out the way I wanted it to. Oops. All right. So let me just retype it in. So we have 2x squared plus 1, no, plus 5, sorry, divided by 3x squared plus 1. Okay. So now if I go to my graph, okay, this looks a little different. The overall shape looks about the same, but in this case now it looks like I'm not approaching 0 anymore from either side. It looks like I'm approaching some other number. It's hard to tell on the graph, but I can go to my table of values and I still have the same numbers plugged in here because I chose those. And you can see that all of the y values are the same, which is 0.666666, which is another way of saying 2/3. So I'm just writing down y equals 2/3 as my answer over on my notes, which we'll get to in the next video. And let's try the third equation. So the only difference between the second and the third one is that this exponent changes to a 3. And then let's go to my graph. Okay. So again, we still have the same like bubble in the middle of the graph here, but now it doesn't look like my graph is approaching any single number in either direction. It actually looks like it's following some slanted line, not a horizontal line. And so I'm going to say there is no horizontal asymptote. That's what I'm writing down on my notes. And we're going to get back to that on the next video. And if we want to confirm this, again, we can go to the table here. And I can see it when I plug in 100,000, I get 66,667. When I plug in a million, I get 666,667. That's not approaching a single number. It's just getting bigger. And here I got negative 66,667, and then I also have negative 666,667, and so those are just getting smaller, and we saw that on the graph. We're getting smaller as we go to negative infinity. We're getting bigger as we go to infinity. We're not approaching a single number. The number is changing, so we don't have an asymptote horizontally. Our end behavior is not asymptotic, as the mathematicians would say. All right, I will see you in the next video, and we can go through the rest of the notes so that we can then begin putting this all together in graphing.